and so we'll probably not have this call. So I hope that's okay with everybody. The survey I sent seemed to indicate that that should be the case. And so I hope everyone has a good time at OCP that gets to go. We had a couple of things to cover today. I need to see that we do have the right people on the call. So one of the items, I want to share my screen over here, is this one. Hopefully you guys can see.
Yeah, we can see.
Okay, this is a submission from Marian and Chris about maintainer process for the Dash repo. Did you guys want to cover this before we go into the Sci Challenger time slot?
That would be Marian can make a brief comment.
Marian, did you want to? Yeah.
Yeah, sure, I can do that.
Okay.
So basically, right, so what we have today is a set of contributors to this repository, and I feel like we are missing some more standardized process for doing the reviews of every contribution. So since we are following everything on GitHub, I thought we can utilize the GitHub tools. And it has some things like starting with the code owners file, which provides an ability to assign reviewers or the code owners for particular parts of the repository. So we'll start with simply having Microsoft just being the code owner for the whole repository since they have initiated that. And for start, me and Chris being the maintainers of Dash pipeline. And besides that, what I want to propose is to enable some of the submission requirements into this repository, meaning that we want to make the main branch protected in a way that all the changes need to be in the form of the pull request, which I think is natural. Everyone would agree with that. So that we won't miss anything. There won't be any commits done without notifying the community, and also requiring the code owners to sign off or to approve on those pull requests. So the code owners themselves, the list can be extended as well. So if there is a company or an individual that has made contributions previously and they have a track record and they would like to participate in this process, they can just generate a pull request to assign them to some part of this repository as well. So it's all flexible. And yeah, so this should be the process. Like code owners should be able to see all the pending changes that are being proposed to the directory that they are responsible for. They should review it and put an approval or request changes.
So it made sense to me. What did everyone else think?
Yeah, no, I mean, yeah, we should, I think, follow the, the SONiC community practice, right? So I would agree, we need to set up some process to make sure, all those PR being tracked and that we have formal PR for those things, right? So I think for the ownership, I think we need more discussion among, those communities probably not being able to, address it in current meeting, right? So I think we need probably more discussion on, how those, subdirectory are owned, right? So I saw, the Dash pipeline is probably a little big. There are different subject under that directory as well.
Yeah, so for example, Gohan, there might be owners of documentation, high-level documents might be one group of people. detailed implementation of certain things might be another owner or owners. Is that what you're saying?
Yeah.
Yeah. We could have a meeting, or we could also just kind of grow this organically, an item at a time, right? Whatever, it'll be obvious, I think, in the beginning who belongs to what, or someone could just, like Marian said, do a pull request. Hey, these 4 people from Microsoft might want to be owners of the specs, plus some other vendors, for example. But you're right, there needs to be some partitioning.
Anyone else?
Marian, did you want to mention that part of this, part of the implications of this is people will need to sign off on every commit going forward? Is that still true, or is that an option?
Oh, I think that's not mandatory.
Okay. In many repos.
Yeah, since we are utilizing GitHub, a little bit heavier signing off is not that necessary, since the approval will still be needed from the GitHub itself.
Yeah, I think maybe we can hold off on that because it's going to become a real impediment. People are going to find out. I do it all the time when I submit to SCI. I forget to sign off, and I have to go back and fix it. And I see people who are old pros doing that too. It's just kind of a nuisance. But at some point, when we get even more strict, we'll probably want to do that.
Hey, Chris, what is a sign off? Sorry, I don't know.
It's easy to do, but if you look in the Git log for, let's say, the SCI repo, you'll see something inside angle brackets signed off by, Chris P. Summers or something. What you do is you do git commit -s, and it puts in your signature, which is kind of an attestation, right? That you did this, you're signing up for it. And if you don't do it, and the GitHub repo is configured to reject pull requests that haven't been signed off, you have to go back and amend that commit. And it can become a bit of a nuisance if you get behind in terms of time. You can go back and amend it, and Git even tells you what to type in to fix it, but it's a bit of a chore.
So I thought it was I thought it was automatic, that basically when somebody submits any line of code or any line, doesn't matter, code or documentation, that one is already tagged with the person's name, because it's GitHub name or GitHub, or sorry, Git name or login name or whatever be the case, right? Isn't it true?
Yeah, a little bit more than that, because it's a practice from the Git itself, from the Git methodology, not the GitHub, where you have a distributed set of forks and you have maintainers on those forks, and there is an hierarchical process of submitting changes. So you don't submit a change to the root origin, you submit it to the fork, and then maintainer of the fork signs off as well. So by the time the pull request reaches the root repository, it will have signatures not only from the contributors, but also from the maintainers saying that, okay, I as a maintainer of a specific module or whatever, I signed off on these changes as well, meaning like I approve them. So this is not necessary if we are using GitHub. So that's why probably it's not gonna be required.
Okay, got it. Hey, thanks a lot. Thanks for explanation, both of you.
Yeah.
Awesome.
Is this for documentation PRs or all PRs? I missed that. Which subdirectories and yeah.
Yeah, it's for all the repository, but the maintainers themselves will be assigned to specific directories. So there will be different maintainers for the documentation, from those who are doing changes to the pipeline, the tests, etc.
Okay. Yeah, and maybe we should have a place for people to sign up to become the code maintainers if they like to.
Did you
You
say
just
we would?
made a
Go
change
ahead.
to the code owners file, but as Goan said, probably it needs a separate discussion.
Yeah. Yeah, we should have a file for everyone to sign up, and then we should also have another discussion. Yeah. Yeah, either is fine.
Okay. Got it. So I hope we've covered that topic enough. We had a second one. Let me grab it. So I don't know, you guys, if everyone see, especially the newer folks, these are the notes that I send out once a week that cover everything we've talked about in the meeting. It's a brief overview, agenda items, who attends, what meeting we're on, like we're on number 41. And then just a brief discussion. And then sticky links at the bottom, et cetera, and links to the recordings. But we said we wanted to talk about PsiChallenger framework again. So I want to stop. I'm going to stop presenting and let you guys take over.
Thanks, Christina.
Mm-hmm. And
And
people on the
might-
call, just make sure you're in that Google group and you'll get those comms.
So is my screen visible?
I can see.
Great. Okay. Hi, everybody. This is a continuation and a bit of a wrap up, let's say, of this phase of our project where we're enhancing PsiChallenger. And we presented on this 3 or 4 weeks ago, sort of a snapshot to get some early feedback. And now we're going to follow through on our promise. We plan to release this, hopefully with a pull request this week that people can review. So what I'll do is we'll go through and do a little recap. And then Anton from PLVision will actually present another demo and talk a little bit more about some of the details. Then we can have a discussion about it. So just to recap briefly, here's our agenda. I'll go through the recap. So we had analyzed the testing requirements and realized that some of the existing methodologies would be kind of pushed to the limit to test Dash, especially the scale issues, the size of tables, the size of configurations, and also the fact that we want to test on real hardware. And existing methodologies such as PTF have a great role, but they don't necessarily fulfill all these needs. So we wanted to take it a step further. And PsiChallenger is an existing framework that we decided we wanted to build upon and add some of these capabilities. And so I wanted to also recap on this Dash testing maturity stages that I put forth last year as sort of a mental framework for how we're proceeding. And we're kind of getting into this phase here where we're testing software device under test, the behavioral model using PsiThrift, and that's in place. That framework's there. We're starting to add a few test cases, but it's still just a software model. We don't have vendor implementations that have a Thrift server yet at our disposal. So we're still waiting for those to be able to do that kind of testing at line rate. But we have a software version of this right now in the repo running CI tests every time you do a pull request. And another stage that will follow as vendors start implementing their SONiC integration, there will be a Redis interface or a Redis database that you can do tests against by using PsiRedis library from the SONiC repo. And that allows you to make database CRUD operations into this Redis DB, and those will propagate down through syncd. And we believe this is a very important and valuable integration step towards the final picture, which is this one here, where you have full SONiC integration using not only the regular normal parts of SONiC that we're all used to, but also the GNMI interface to do northbound SDN type operations on the Dash pipeline. So these are the stages we want to go through, and we put in a framework which we believe will support us all the way to the finish line. And this is also not exclusive to the traditional SONiC management testbed, which is out of scope of this meeting, but we believe both of these play an important role. And Anton can talk a little bit about this stage 4 when he presents, because it's not well understood by everybody, but experience has shown that this is actually a very valuable intermediate step. Any questions up to this point? This is sort of a review.
can you go back to this previous slides?
Sure.
What is this side challenger? I may, you know.
Okay. I'll give you a brief description, but I think Anton can do a better job and provide a little more background. But it is a Python.
Because sorry, there is already a, you know, I think some topic about side challenger that is developed by I think a company, what is name?
PLVision.
Yeah, is that the same?
Yes. Yes, and
Oh.
we so Gohan, you didn't make the last meeting, so I'll provide a little more background. Keysight engaged the services of PLVision to extend their framework for helping along Dash, and we're contributing that to the community, and we're also incorporating that into the Dash test pipeline and workflow, and we're going to use this as the basis for doing ultimately line rate testing on large scale Dash configs. So if you follow the story as we recap this and then go through, I think it'll become clear. But
Okay,
yes,
so
this the same framework.
No, but I don't understand this one, right? So, side challenger, I think is a way to, to invoke side commands, right? So, but we already have a side script that allowed us to, invoke side commands. So why we're doing, the two things here?
Okay.
Why we have a side script and also as well as a side challenger?
Okay. I think as this presentation unfolds, it'll become a little more clear, but I'll try to address that briefly. When you look at the scale of Dash configs, and we're going to be talking about something called our side generator in a moment. So if you want to watch the rest of the discussion, I think it'll become more clear. But in general, the size of Dash configurations is pretty huge, and it's hard to generate them programmatically. And we've created a set of tools that make it very easy to create large-scale configurations, such as the hero test, with very little effort on the part of developers and test writers. And we've encapsulated a lot of the expertise required to do that into this framework. And hopefully it'll become more clear as we proceed through this presentation. And if it's not clear when we get to the end, I think we can try to close those gaps. So if you bear with us, I think it'll become much more obvious in a few minutes. But yeah, that is why we did this, to handle the unique needs of Dash. And having said that, everything we've done here is applicable to standard SONiC or anything that uses Psi. It's not even dependent on SONiC itself. So people are using Psi for other things. The enhancements that we're making are applicable to that as well. So let's say if there was 2 words I could tell you in an elevator between 3 floors, it would be scale of configs and line rate testing, and a smooth transition from software-based testing to line rate testing. So what we're doing is we're contributing, PLVision is going to be contributing side challenger enhancements that we sponsored and helped define, and Keysight is integrating this into the Dash repo and contributing that. And this will all be open source, everything. We want to increase developer productivity, and we actually already have a staged branch with these changes in that we hope to polish up by the end of the week and submit a draft pull request for people to review. And that will probably take a little time to bake, but I've already done trial integration of this into the Dash pipeline last night, in fact. It's already running.
Cool.
So again, this is a recap about the overall architecture. It's kind of a one view of it. It doesn't really show side challenger in all its proper glory. It's sort of a filtered view of it from my point of view and how it relates to Dash. But what we have is side challenger in the middle. And side challenger is fundamentally based on PyTest, which is pretty familiar to people writing SONiC management tests. And what we've added are things on the input side that help you create complex Dash configurations, including different ways of representing the configuration, You could write programmatic code like people are used to, and Anton will show a script snippet, so you'll see what it looks like if you haven't written those kind of tests. You can also have text records. We call them SI records. It's not the same as the SI recorder records that people in SONiC are used to. It's really based on an abstraction of SI configuration that can be rendered into different forms for different APIs, and we'll explain that. You could have files, so you could have arbitrarily large configurations in a file as well, and then just import those. And finally, we have this, what we call SI generator, and we have a variety of these generators. We presented, Mircha, my colleague, presented a Dash generator several months ago. That's in a kind of a long-standing pull request in the Dash repo that generates kind of an abstraction of Dash configurations. We've got a customized one that's generating SI-based configurations that creates records for every SI create action, for example. Now these configurations for Dash can be very large. To give you an example, the hero test, if you emit a JSON file representing the hero test configuration from this generator, it's 1.3 gigabytes. So that's the scale of really large tests. And there's smaller mini hero tests, micro hero tests, baby hero tests. There's a lot of different scales, but some of these are really gigantic. And to try to figure out the logic of all the different nested address fields, all the permutations, all the dependencies, it's taken months and months of expertise to even master that. And we've incorporated it and encapsulated it into a very easy to use Python library that can be extended by the community. So that's one of the contributions. Now, all these different input formats for complex or even simple SI configurations get read into some helper classes that then parse those records and apply them to the device under test, whether it's hardware or software. And initially, SI Challenger came with a SI Redis driver. That was its raison d'etre, was to test through the SONiC Redis portion. Part of this project now is to create a SI Thrift driver. So this driver is using the results of the SI Thrift auto generation code that Intel created and contributed in the previous months, which is already incorporated into the Dash PTF test bed. Now we're taking the same contribution and we put it into this SI Challenger framework. So we're using the same drivers, the same APIs, it's proven, but we can do SI Thrift calls. So just with these two now, we're able to write test cases that can apply to either interface. And this was one of the visions that we talked about as far as a year back, where you write one set of test cases that can apply to multiple APIs. So to put that into context of this drawing here, I could write Dash-based tests here and also run them in this environment. And you've then just proven multiple layers of the stack.
Can you go back, to the next slide? I think so. Here, I get there's a configuration generation part, right? So totally get it. But I think the SI Thrift and the SI Redis driver, is basically same thing allowed you to talk to the DOT through the site, right? So my concern is that now the community have to maintain two drivers in order just to achieve the same goal. I mean, is there a difference that they, in terms of functionalities? But
we're not maintaining two drivers.
Who is maintaining this SI Redis driver?
Well, this SI Redis driver is already part of SONiC.
No. We didn't. We never use the SI Redis for such communications, right? So.
Well, I'll let.
Yeah,
Okay,
I'm a maintainer of SONiC, right? So I'm not aware of that. This SI Redis could be used for for external communications to the site. I'm not aware of it.
Okay, I'll let Anton address that question since he's got more hands-on experience with that. But PLVision's been using this for probably over a year, right? And there have been vendors using this successfully in their operations, not necessarily all public.
Yeah,
so
but it's not a supported scenario.
Okay.
From our perspective.
We can address that, and we may find that this merits support if it gets uptake. But this isn't really the focus of our current activities. It'll come into play as vendors start integrating SONiC, and I think it'll prove itself or not. Right now,
another question
yes,
is that the scale config that is there on the left side that Mircea has been talking about, I think that is of a great value. So can we apply that to side thrift layer?
sure. This code will be a nice Python utility eventually, and Mircea can talk more about it a little later. But yes, we actually proposed that in the last meeting, that all the work we're doing here, bits and pieces of it can be harvested for other places like PTF. Yes. And it's just a matter of plumbing, right? It will be pretty obvious how to play with it, and you can use it however you like. So this is a bit of like intellectual property that's, I don't know, I'm going to say it's got multiple man months of know-how baked into it, with our engineers working with Microsoft and with different DPU vendors to abstract and encapsulate the logic of creating large dash configs. And it's proven. Right? We have variations.
Yeah, we should. It will be good to discuss how much effort it is to use that in the side thrift, and who can do that and when can we do that.
Sure. That
sorry, before that, I'm still, the message I'm trying to communicate, right? So is this, using the side Redis channel to talk to side is not supported by SONiC community, right? So, so I don't understand that why we are trying to base our solution on unsupported components here.
Okay.
May I try to answer like this, Anton?
Hi, Anton.
Yeah.
Okay, so see that so this is not like for testing end user scenarios, it's for development testing, first of all, because SideChallenger is actually contains like two components or two ideas behind a feed. Like first idea actually is this kind of SONiC short stack where we have only syncd and Redis, and it's extremely useful when you're on the development stage. It's not like final product, but it's a development stage where you do an initial integration, because you don't need to have all a bunch of components. You have only two first one when you just have your libsci and you are integrating in some place. And at this stage, you also want to test something. And here, side Redis is pretty useful because we can use some record files and try out real world scenarios so that we can check whether it will work. And we are testing it we are testing it in the environment which is pretty close to the final SONiC environment, because you are sending some commands, real world commands that you has recorded somewhere, and some even probably live infrastructure, and trying out it in the short stack to identify what's going on there. That's actually the first value for the development. The second value is actually that you can try some specific tune, because based on our experience in the development, we find out that it's pretty often people want to try some custom sequence of commands and of SCI commands when we are talking about debugging SCI issues. And yet again, we want to try them out in the real environment, not like isolated some libsci, for example. And if we have some rec file from the real system, we can just replace them, and we can then edit them and add some custom scenario to ensure that it will work not only in that specific case, but only in some other cases as well. So that's side challenger is not like a different way to send side comments. It's like let's
So sure. I mean, we did look at those side challenger when they first come up, right? So I think for example, one of the problem we're aware of is that those code, right? So I think we talk about the side shift. It basically has automatic generation framework, allowed you to define the new side PIs and then generate the code and then build the libraries, right? So I don't think those the side Redis, which is the base component that supports used by side challenger, it have that capability. So we do not have that capabilities on that part. So for the new APIs, you need to craft this amount. For the side Redis, it's not automatic supported. So that's what I'm saying, right? So we have never designed the side Redis to be used in these cases.
But on the other hand, like so Redis comments are almost like the same what you have there inside. It's also
Yeah. But whenever you define some new APIs, which is the case for this Dash project, right? So we define the new APIs, you automatically generate those side headers, right? So those integration are not there.
Yeah.
Some I need to work on, right? So because
Yeah, go ahead. Let's take a note and maybe we can move on. Your concerns are valid, and I want to just point out the focus of the presentation isn't about Redis driver. That's already built into Side Challenger, and we didn't actually have to do anything new. That's already there. We use this framework, this excellent framework, to add this, which is the focus of our current Dash efforts. And I think that's the value we're trying to explain here. Even if you just forgot this was on this diagram and we didn't talk about it anymore, this whole deliverable that we're creating is of immense value. So I'd like to take the focus away from this for the time being, and we can talk about it further. But I would like to get through the rest of the presentation and a demo, because we're gonna demonstrate this also, and that's really our focus right now. Is that okay, Gohan? This can be an ongoing discussion.
Yeah, let's not destroy that. So let's go ahead. We can have another meeting on these concerns, and then I'd like to see the full demo.
Great.
Yeah.
Thanks.
I'll take a note to set up a call about that. Thanks, guys.
Great. Yeah, it's a good point. The maintenance of the side Redis, that does need to be factored in. So thanks for the question. It's all good.
Awesome.
So again, we talked about the generator, and I went over this in the past. Just want to do a very brief recap. Think of it as a master generator that calls sub-generators. And these sub-generators can generate the configurations for different components of a Dash config, like ACL groups or ENIs or CA/PA validation. It creates all these in sort of a hierarchical way. And you can specify just a few high-level parameters, give it to the generator, like let's say scale and step values and scaling. It will generate all these records. It can be a JSON file. You can go to your console. You can use it as a library and iterate through records. And we import this into Side Challenger and use it as like just a generator class. And so you could say, give me this hero test scale, which is just, 20 lines of parameters in here, and get, hundreds of thousands of records, 600,000-700,000 records out of it with almost no effort. So that's the generator, and this generator can be tailored and tweaked. People could even use this as a basis for creating their own in-house generators for their protocol. If you wanted to take the logic of the generation and create, gRPC records for your implementation internal, you can do that. This is meant to be extensible. So what I wanted to do was, at this point, turn it over to Anton, and you can take over the screen share if you like. He's going to talk about the components a little bit from the PLVision's point of view, and also do a bit of a demo, and he'll talk about some Dash configurations. Anton, you ready to go?
Thanks. Yeah, and let's try and
sure.
Great, let's go.
Okay, so here's the same slide that
Anton, we can't hear you very well.
Yeah.
Speak a little louder. There.
Okay, so is it better? Like
Yeah. Thank
okay.
you.
Okay, so this is the same slide actually that you stop in. So that's what we actually added from the last time. So this is difference. Last time we described the idea of having the test configuration, which actually a dash config that we take from the HLD, but we added some amendment to make it easier to use for high scale configuration and do not have 1 gig configuration files. And the another idea behind of that having the test config and the amendment to it is that we are using it as a single source of truth for both for generating the configuration for the device and for the configuring traffic. So we have like two libraries, and we are using the same source for SciGen, which actually then generates Sci commands like that are then translated to the Thrift or to the Redis, like whatever. And the idea behind is that we can have any custom API that, if needed, like by some vendors in the development stage. And from the traffic profile we are generating right now, so that's we are switched to the Snappy, only because at this demo I will be using a scale scenario, and the idea is that we will have line rate traffic like in the future, and it will be running on probably some hardware Xia, but right now I'm using XCC. So single source of truth, then which is used for device configuration and traffic generator configuration, and all that is fed to the Sci Challenger, which is actually control our test bed there. Okay, and before actually showing the demo how it works, I would like to give some ideas about the scenario. So I want to say that the idea is to show the tool, not to like to say about scenario. So right now this is, let's say, small scale. The real configurations that I am applying to the BMB2 model. So that I have a single VIP, I have 2 direction lookup, I have 2 mappings, 2 ENIs, 4 outbound routing entries, and 8 PA2P routing entries. So the idea actually is that in that configuration we can scale that, in the test configuration we can scale that configuration and add more items here, for example, not 8 but 8,000, changing just let's say one entity, saying that okay, so that I want the 8K pay-to-pay mappings. How we do that? So let's take a look. But like I want that you just check, because I will be then returning to that picture because this is the real configuration that I will be using in the BMV2 model when I will be running test cases. By the way, just for understanding, so that's all entities you can like link probably like in your mind to the well-known picture from the HLD. So that's what we are configuring in our test case. And here is how test configuration look like. Last time we actually had a short view, but we didn't actually talk about scaling. So here's the idea that instead of defining, for example, 1000 VNets, we can define some dash VNet entity where we are putting some structure, dictionary, like in that case, dictionary or JSON. So that's as you wish, because it's a matter of format. You can write it in YAML and just import to the Python. And I'm putting the count what I want to configure. And I said, for example, if I set 1000, it will mean that I will start from 1000 value, and then with step 1 I will be adding 1001, 1002, and so on and so forth. Here is more complicated part with like 2 counters inside of it, but yet again, so we do not list thousands of entries, because for the scale configuration we will have thousands of entries. We are just defining how many we need, which step, and some relations. For example, here we have a link to the ENI item. It means that it will be linked to some specific ENI. And that's it. So then SciGen will generate a configuration that will be then be possible to apply in runtime. So because it's generator, we do not really need to store the whole config because it could be extremely big. Somewhere in the RAM on the disk, we just will be like applying it entry by entry. Here, just also to show that the idea behind it, because here the exactly same configuration, so that's outbound routing entry. That is not the scale one. I want to say that is a basic one that we showed last time, and this is the amount of Python code that you're like used to see in the Swift. But I want like just to emphasize that eventually it will be translated to Swift. But for test designer, like it might be much easier to write the configuration and scenario in the Dash way. Here I do not use any dictionaries to make field configuration for easier understanding, but like test designer will be working with that. Then our framework actually will translate that part of code to the Swift calls, like inside. So that's how Swift driver works in the Sci Challenger. So, like, see that much easier to understand what's going on in this case when you have some short dictionary. However, like, it doesn't mean that you cannot use directly Swift. Like, up to you. If you really need, it's still there. So, like, it's still a part of the framework. Also, something that I showed on the previous our meeting, but want to remind, this is how the same entry is translated to our standard Sci representation. That's something that we are using to feed to Sci Challenger, because if you need, like if there is a need for tester, it's easier actually to write a scenario and the configuration directly in the Sci records. Like, for example, here I have type Sci outbound routing entry with keys, with attributes. It's actually all well-known keys, like operation create, so nothing new. Like that's the standard Sci keys that we are using, and it's possible to write test case using a direct string. But what's one like of the idea behind having this format is that because we then can translate it to multiple drivers. Like right now we have Swift Redis, but we can have something specific. As I mentioned, if some vendor is an early development stage and want to translate it to some other API, you're welcome. You can have some internally your own driver and check real scenarios that verify it and work with Swift. You can check with custom API to ensure that it will be working in the future on your device. And another very important advantage, this is a text or Python structure which can be scaled pretty simple, pretty easy, so that you can just multiply those values and generate them in the runtime very easily in the Python code. So it's easy to read and easy to understand actually what has been applied on the device at some stage. Okay, so definitely if I will have some incrementation here, so it will SciGen will generate multiple such entries that then will be translated to Swift or whatever driver and applied to the device. So this is the idea behind it. So right now I will show the demo of the framework. I will be applying that configuration. That's one. But before showing the demo itself, I would like to give you some idea actually about the environment that I'm using for it. And here is it. So setup. actually prepared like 2 setups, and I wanted to show that actually we can have a single entry point for running any test cases. And that's the first setup that I will be using. So that's our site challenger container, which we have created dash site challenger client. Inside we will have the test cases written in using the test configuration. Then test config will be through the SideGen, through the helper function for the traffic will be translated to the site challenger, and we will configure. On one hand, we will configure XCSC. On another hand, through the Swift driver, I will send actually the framework will send that command to the Swift server and to the apply to the BMV2, and then we will do the verification. So here I wanted to show that exactly the same schema can be applied with another drivers. Like so far, unfortunately, we do not have syncd ready for the BMV2. What I would really like is to try out that it works on some higher upper integration level and ensure that, like for example, same scenario works on all levels of development stages. In future, like we might even want to have some GNMI driver and see that when we build the whole system, it's still same configuration still works. Like we can write once some scale config, we can write once the test configuration verification stages and run it on a different development stages of our product. So right now I won't be switching between PTF and Snappy because I will be using some advanced traffic configuration. I will be using Snappy with flows and incremental data, and it's actually intended to run it with a line rate. So okay, so I see that we will run out of time, but I will try. So here I have 3 windows. First, I will actually run the switch. So this is a BMV2 model. Here I have Swift server. That's my DUT is in place. Now I need to run test. So like last time, actually, I was running test case from inside the container, so that was a lot of steps. Right now I have actually single make command. I have 2 test cases. I am able to select what I want to run from the make, but I can run everything in one shot. So let's try. It's doing all deployment of the XCSC, running all scenarios, applying the configuration, and so right now pass. So that's outbound routing scenario. What's new here? So last time I showed only PTF based packet, which actually does verification of the old fields of the packet. The packet is translated through the configuration correctly, so that all fields are updated as we want. And the second test is using Snappy. Potentially like right now through the XCSC, but potentially through the X network hardware traffic generator, which is supported in Snappy, and it creates flows with the actually that can be applied on the line rate. So right now I'm sending one packet because it's BMV2, so like I won't be able to run more. But like the idea behind that we will have a more complex scenario. So that was simple test case with one packet. And let's see the scale test case. So engine's name, scale one, and here I have 2 test cases. We will commit to the PR for the community 2 types. First one is a fixed packet count, and the second one is that I'm sending some fixed time. So that's for the 10 seconds, I'm sending just on a line rate packets, and I'm verifying that all of them like just finished the end. So for BMV2, I was using 20 pps, it's more than enough. So like able to, at least in my environment, use more. But what's interesting here right now, see that I do not, I have in my scenarios, you remember, of 8 CA to PA mappings, and I want to reach each actually possible path in that scenario. I want to show that I want to reach that path from VIP through the all ENIs through the outbound routing to the CA to PA1. And I want to reach path 2, 3, 4. Actually, I'm trying out all of them. And here, how I figured it out, so that we doing incrementation on the, at this particular scenario, we are doing incrementation on the customer address destination IP. But like it based on the our config, because we are able to do incrementation also source MAC in for the customer for the direction lookup entries. So see that for the virtual IP addresses also it's allowed. So, but for that specific case, I have only 2 flows. 2 flows is enough because I have that 2 parts are fixed, and I only doing incrementation through the CA tip. But like that's an example. So we can have more. More than this, we will submit a PR with example with those test cases, and you will be able to try out to see how it works. And also, I want to just remind that it's possible to run same test cases on the different environments. One of the options that I'm using here is that just JSON configuration where the testbed is described. So the testbed I was using and showed in that on my slide is described in the JSON format here. So that's I'm using DPU. I'm using as a driver. I'm using Thrift, some addresses where to connect to which port. As a data plane, I'm using right now Snappy, also some information about the ports and so on, but like I can use PTF. Here I can also use Redis. So that's flexible, and the idea is that same scenario can be applied in multiple ways. Okay, so I see that it's like close to the end, so I would like to, if you have some question at this stage, so please let me know.
So any technology provider can use these tests?
Sorry?
So anyone on the call could use these tests once the PR is submitted?
Yeah, sure. So
it's amazing. Thank you so much.
That's all open source because this is an open compute project, so that will be all these changes will be pushed. So
wow.
We plan to do this week, so we'll see how. Because I forgot that we have some holidays plus OCP, so like maybe early next week, but like anyway, everything will be pushed. So Redis part.
That's amazing.
So let's if I have time at the end, I will show, because actually everything I need to switch to a different type of DUTs. So it's not just a different type of like drivers. So see that I have DPU here. Here I have NPU. I have different type of driver. I have, okay, so in that specific case, still XCC, but I can have, I have example. I have
Anton?
PTF. Yeah.
Anton, can I interrupt, please? Maybe we'll defer that, because it sounds like there's going to be a longer discussion about Redis. And we just have
thinking, Chris, that we're going to need a Q&A
so like
for this.
We'll skip that part of running test cases. The only last slide that Chris, we can maybe show that some advantages why we decided. So that slides we already discussed, so I will keep it. Okay, and that's one. So why we actually selected, because we need to have some abstraction level. for
Yeah.
different DPUs, and we need to have some abstraction, like well, actually for the wall test bed, because our intention was to add Snappy, and PTF also is here. It's also still available. It was initially part of the SAI Challenger, and right now we added Snappy, but the idea of that we already had some abstraction. I just showed you a JSON configuration that allows you to easily switch between different types of the configuration. The next huge advantage is this is PyTest based, because it unlocks the whole ecosystem, plugins, and integration. So that's actually like even just a selection of the test cases, what to run, what to not run. It's a lot, I believe, in comparison with what we have. And here we are just using still with same PTF, still with a Swift, but we are able to select test cases. We are able to add some plugins, integrations, whatever exists in the PyTest world. Like SONiC Light Stack is a good one for SYNC development. That's proven by a few teams. Factorized environment already there. Testbed agnostic test cases, that's because of that abstractions. That there is also multi-DAT support. So if you need to try out few DATs in the same setup, it's there. You can try it. You can build such setup, and you will define in JSON multiple DATs and it will work. So that's the OCP project. So what we added during our activity is that we multiple DAT API support. So we added Swift, and we allows to add any custom driver, vendor specific driver, if needed in the development stages. And it included Snappy support. So that's also very important part, because it unlock us from for the performance and scale testing. So that's the most important actually thing that we like to see in the future. In the
You know what I'd like to do? You know what I'd like to do, Anton, is when we pick up week after next, just as a reminder, we could rerun, the live test so we can remember where we were, and then pick up with a Q&A session, if you wouldn't mind.
Yeah, sure.
I think that's a good idea. And we have some next steps too, which we don't have
There's
time
just
to
a
cover.
lot to cover, and this is amazing. Thank you so much. I know we're at 10 o'clock. I hope that works for everybody else. Since we have the week off, we'll just do a reminder of what we went over, and then, we can start off, because I'm sure there'll be a lot of questions. Does
we'll have
that
a
work
draft.
for everyone on the call?
Yeah, thanks, Christine. I think that's a good idea. We can do.
Yeah. And
Just
then if, Anton, if you would share the slides just with me, krisny@microsoft.com, so I can go over them again, would be awesome.
I can upload actually to the repo.
Oh, that would be wonderful. And guys, it's 10:01. I know everyone probably has to leave. I'm going to stop the recording. Anything else burning?